Set the tape at 35 feet, point zero. Holding steady at the mark.
It's shifting on the left, watch yourselves. We need that next brace secured now, hammer it in. Keep it moving to the left. All right, hit the vibrator over here.
Moisture control is critical. Foundations gain strength rapidly.
Steel anchor bolts are set into the curing concrete. Bolt patterns match steel column bases. Future alignment is locked in.
Foundation caps are completed and exposed. Concrete surfaces are smooth and level. The site is ready for steel. Steel columns arrive by rail and truck. Each piece is prefabricated off-site. Sequencing is meticulous.
Temporary steel derricks are erected on site. They will climb with the building. Vertical logistics are planned.
All right, the sequence is critical here. Beam 7 goes up before the truss assembly on level 3. Confirmed. We'll secure the west side first.
Temporary bracing connects early columns. Lateral stability is ensured. The skeleton holds firm.
Foundations complete. Steel rising from bedrock. The race skyward has begun.
Steam rises as rivets cool quickly. Timing becomes critical at height.
All right, lower the next plank, watch it on the left beam. Got it. Careful stepping over that gap. Secured this end, moving on.
Interior shot of derricks climbing upward with the building. The cranes are reassembled floor by floor. Vertical logistics stay efficient.
Close-up of riveted joints cooling and tightening. Thermal contraction increases clamping force. Connections grow stronger over time.
Diagonal bracing is installed between columns. Sway resistance improves immediately. The frame stiffens with each bay.
Wide shot showing floor framing completed ahead of facade work. Steel erection stays far ahead. Speed defines the schedule.
Sizes reduce slightly with height. Weight efficiency improves.
Plumb line shows we need to shift slightly left. Okay, applying pressure, is that true? Locked in, tighten it down. This is where we start the next section. All right, teams, let's get those rivets placed before sundown.
Temporary bracing is removed once bays are locked. The frame carries its own load. Deflection remains minimal.
All right, bring that beam down slowly. Hold it, a little to the left. Coming down, watch your hands.
Close-up of beam to girder connections near the core. Heavier members handle concentrated loads. Structural hierarchy is evident.
Hold that beam steady. The wind's picking up, watch the line. All right, secure it now.
Close-up of smaller steel sections used higher up. Member depth reduces gradually. Material savings compound.
All right, hold it. Holding steady, ready to set.
Close-up of columns terminating at the setback level. Load is transferred into heavier girders. Structural continuity is maintained.
New column lines begin above the setback. Spacing tightens as the footprint reduces. Vertical loads realign smoothly. Steel framing around elevator openings is reinforced. Heavier beams handle concentrated loads. Rigidity increases locally. Tolerance remains extremely tight.
Diagonal bracing density increases at setback transitions.
All right, bring it down slowly. Watch the alignment.
Wind visibly flows through the open steel frame. No large surfaces catch pressure. Design minimizes wind load.
Close-up of alignment checks at upper setbacks. Plumb lines confirm vertical accuracy. Corrections remain minimal.
All right, bring it up slowly. Clear the left side.
Reinforced steel around core openings is completed. Elevator zones are now continuous. Systems integration advances.
The Empire State dominates the skyline. The race is visibly won.
All right, bring it down slow. Hold it right there. Looks good. Set.
Despite height, quality does not drop.
Limestone panels are hoisted upward by derricks. Each panel is sized for rapid placement. Exterior work begins floor by floor.
Limestone panels are hoisted upward by derricks. Each panel is sized for rapid placement. Exterior work begins floor by floor. Ventilation shafts are framed vertically through multiple floors. Large openings penetrate the steel grid. Load paths redirect around voids.
Close-up of steel reinforcement around shaft openings. Extra plates spread stress. Crack prevention is built in.
Rapidly. Cycle time shortens.
Upper-level facade panels become narrower with tapering. Stone weight reduces with height. Load efficiency improves.
As the steel structure rises, the lower floors are completed and become fully operational, demonstrating the efficiency of optimized vertical sequencing.
Wind effects increase near the upper floors. Temporary screens and bracing control movement. Work continues without delay.
Facade anchors adjusting for steel movement. Slip connections allow expansion, ensuring cracking is avoided.
Upper mechanical systems are hoisted into position. Equipment fits precisely within framed bays. Access is extremely tight.
We need to ensure the connections at high elevation meet spec.
The rivet patterns must be perfectly consistent.
Easy now, easy. Guide it in.
Almost there. Hold it.
All right, secure the bolts.
Temporary derricks are repositioned near the top. Lift paths shorten dramatically. Endgame logistics begin.
Alignment on this side.
Look straight, set it down.
Slip connections allow thermal movement. Surface finish becomes reflective. Preparation begins for the mooring mast structure. Slim steel sections are staged near the top. Lift paths are extremely tight.
The mast base frame is installed above the crown. Connections are compact but heavily reinforced. Vertical loads concentrate here.
The skyline changes permanently.
Interior view of mast support framing. Bracing ties directly into the core. Sway control is ensured.
Wind conditions are observed at full height. The building shows minimal perceptible sway. Open steel logic proves effective. Interior stair and service routes are finalized. All vertical systems connect seamlessly. Operational readiness increases. Exterior facade inspection continues from multiple elevations. Cladding panels sit flush and aligned. Thermal gaps remain consistent.
Bring it down slowly. Hold it right there. Watch the alignment.
Final structural checks at the base foundations. No settlement or cracking is visible. Bedrock anchoring holds firm. Steel speed and precision define its form. A new era of skyscrapers begins.